solubility. It is the dissociation of ions in water. So yes, it's whatever dissolves in water, but in AP Chem we say dissociation. Okay, big word. So it's ions being able to dissolve in water, and at the atomic level, you would be able to see it separate. On Monday, I have a demo for you. Remember the light bulb? Whoever I had different solutions, and then I tried to see if the light bulb went off. We'll do that because I don't know if everybody has seen that. So we'll make sure that we do that on Monday. Now, an electrolyte is anything that can conduct electricity. And the only way something can conduct electricity is through the dissociation of ions in water. Can it dissolve in water? Okay, so what is an electrolyte? An electrolyte is due to dissociation. Electricity is conducted. So because it can dissolve in water, it can conduct electricity. Yes. Yes, it's a very weak electrolyte. And we tried Gatorade. And we tried Powerade, and one of them was actually a better conductor, but yes, it has electrolytes in it. And now you're like, so you hear about that. Oh, I need my Gatorade because I need some electrolytes. Well, what is an electrolyte? They have to be some sort of salt that dissolves in the water that allows you, it re-energizes you, or it gives you that, when you're dehydrated, or it gives you that energy. So we'll try Powerade and we'll try Gatorade, just so you guys can see which one is a better electrolyte, or has more electrolytes in it. Yeah. Now we need to know the difference between strong, weak, and none. So what's a strong electrolyte? What's a weak? What's a none? Okay, so first things first, a strong electrolyte can be any ionic bond. Guys, what's an ionic bond? Very good. I bet you'll never forget that. Metal plus non-metal. Okay. If it's an ionic bond, then if it's ionic bond, it's a strong electrolyte. Also, all salts are strong electrolytes. Now, there's a misconception that, salt is just NaCl. Salts can technically be a metal with a non-metal, or a group 1 with the fluorines group, with group 17. Those are salts. There's a lot of different types of salts, not just sodium chloride. But salts will easily dissolve in water, and so will ionic bonds. Now, most salts are also made from strong acid and base reactions. So, next thing, if you have a strong acid or a strong base. And then I'm gonna go over how you can tell if you have a strong acid or strong base. Strong acid, strong base, we'll go there. Okay, next will be weak electrolytes. Oh my bad. On the bottom, you need to understand that these will completely dissociate and they will conduct electricity. They will completely dissociate, they will conduct electricity. Okay, and then you take a look at the picture. If you take a look at the picture, here we have, let's do another salt, because you're so used to sodium chloride. Let's do lithium chloride. Here you have lithium. I'm assuming that lithium is the positive, and it's a small atom. And we can assume that this is chlorine. When they just together, guys, they are not charged. Because remember, positive minus becomes neutral. When you put it in water, they split up, they dissociate, they tear apart. But when they tear apart, they become charged again. So it completely dissolves in water. Well, look at batteries, don't they have plus and minus on them? So when the current runs, you need to line up a minus to a plus to a minus. And that's exactly what happens. It creates this current, or it allows for electricity to flow. And strong electrolytes will completely, you'll see the light bulb just light up. Okay. Weak electrolytes. Weak electrolytes are all weak acids, right here, and weak bases. So vinegar is a very weak acid. Ammonia, weak base. And again, I'm going to go over right now how you can tell whether it's weak or not. pH. pH will tell you what the pH is, but it will not. It won't tell you is it weak or not. Well, yeah, because if it's a certain color, it tells you acidic or basic. Yes. But you guys, how do you know something's an acid? What does it have? Hydrogen. Bases all have hydroxide, and they have, or not necessarily because ammonia doesn't. But we'll go over how you can tell whether they're acid or base, because you won't have pH strips. You'll just have to be able to assume. Okay, so weak acids and weak bases. These guys partially. Oh my gosh. Okay. Oh my goodness. Dissociate. What am I can't spell today. Dissociate. Right? Yeah. They partially dissociate. Weak acids and weak bases. And there's a very weak current. And usually Gatorade and Powerade are very weak. I mean, there are electrolytes, but they're weak electrolytes. You'll see like salts will light up, or hydrochloric acid just lights up because they're strong. Vinegar is very weak, so you won't see the light bulb light up as much. And if you can't really see in the picture, but it's lit up somewhat, just not a very strong current. And if you take a look here, notice how the atoms completely split up. Here, only some do. So you have a positive cation, but look at these guys stay together, and then you'll have another positive ion somewhere, another positive somewhere. So it only gives you positive ions. It makes it very weak. And then a non-electrolyte completely just does not light, and there are no ions. So we go back. Non-electrolyte is usually carbon-containing compounds. And these guys do not dissociate. They stay together. And there's no current. I think a good example of a non-electrolyte would be like the diatomic molecules. They stay together. I mean, if we were to be able to put them in water, then nothing would happen. If you take a look at the diatomics, nitrogen, oxygen, fluorine, and chlorine are gases. They wouldn't be able to dissolve in water anyway. Bromine's a liquid because it's blue. So the only one we would have as a solid would be iodine, and it would not dissolve. It would literally just stay together, and you would have no charges in the water. Yes, sir. I'm sorry? Iodized salt. Iodized means you have to have some ions in it. So it has, usually iodized salt has been made in a lab. So it's like synthetic. It's something that's made up, and it contains ions. It no, usually it's sodium chloride. Okay, and then this has no current. All right, so here we have complete dissociation. And here we have a partial dissociation. And here, absolutely not even one charge exists. All right. Next. Do me a favor, guys. On the second page, at the very bottom, I want you. I do not know why it's not included. Go ahead and just separate us. Just designate a section like on the bottom. Vacío. And I want you to write strong acid, and then strong bases. Let's go over how you can tell if it's a strong acid. So all acids contain what? Hydrogen. Okay, so how do you know it's a strong binary acid? So first things first, and if it's a strong acid, it's going to have hydrogen. Binary acid, the three strong binary acids are, take a look at the periodic table. See fluorine, she's highly electronegative. She's an electron hogger. Fluorine's going to hold on for dear life to her electron that hydrogen just donated to her. She's not going to let go of it. So underneath her is chlorine, hydrobromic, and hydroiodic. All of them are strong except for fluorine. And if you got that in your brain from Chem 1, oh, fluorine, she's highly electronegative. She accepts all the electrons. She's not going to want to let it go. Okay, so chloric, bromic, and iodic are strong because they'll easily dissociate. They don't mind giving up their extra electron and it going back to hydrogen. Okay, polyatomic. This is where it gets tricky. The trick for ternary acids, those are just binary. For ternary acids, there's a trick. Okay, what does ternary mean? 3. So you obviously have, it's not binary, it's a polyatomic ion with a hydrogen. So you have a hydrogen with some polyatomic ion. And there's a trick. In order for it to be strong, you have to have 2 or more hydrogens than oxygens. For all I know, I'm teaching this next time. I don't remember. We'll just refresh your memory. So for ternary acids, that means a hydrogen with a polyatomic ion. You have to have 2 or more H's than O's. So examples: HClO4. Do you see how there's 2 or more oxygens and hydrogen? Strong, automatically. Oh, I'm so sorry. Sorry, guys. My apologies. Thank you, sir. There's 2 more O's than H's. Thank you. So there's 2 more oxygens than hydrogens. Sulfuric acid. Do you see how there's 2 or more oxygens and hydrogens? For chloric acid, 2 or more oxygens. Nitric acid, 2 or more. Do you see the ratio? That's just a trick, guys, and it just conveniently works like that. These are binary. Chloric, bromic, hydrochloric, hydrobromic, hydroiodic are the only 3 binary strong. But to figure out ternary acids, you have to have 2 or more oxygens and hydrogens. So if you see the formula and you're like, oh, there's 2 or more than that, automatically it has to be strong. Hydrosulfuric is H2S. It's binary and it's weak. The only 3 strong ones are those 3 halogens with hydrogen. So let me ask you something. You don't have to write this down. Is that strong or weak? Very good. Strong or weak? It's 1 to 2. It's supposed to be 2 or more. Okay, this is weak. Nitric is strong. Nitrous is weak. Same thing with H2SO3. Look at sulfite. This becomes sulfurous acid. It's still, there's not two oxygens more than hydrogen. This is weak. Two or more. Because look at, there's a two difference there. Nitrous acid is weak, sir, because there's only a one difference. It's only one more oxygen than hydrogen. Okay, because technically there's a one here. We just don't write it, it's like understood. If it was a three, which nitric acid is very strong. Perchloric acid is one of the strongest acids. And there's actually some with negative pH. Okay. And there's a book you can read. It's an interesting book. The Disappearing Spoon. They actually have it in the library. Oh my gosh, guys, they have it in the library. They have like 3 copies. It's The Disappearing Spoon. And it's about how Mendeleev put the whole periodic table together, and then it goes into the history of the elements. Like how tungsten was found and how they used it in World War II, how Hitler used it against us, and it's like really cool. I highly recommend to read if you have time. Okay, bro? Okay. Bases. How do we know it's a strong base? First and foremost, it has a group 1 element. So what do I mean by group 1, guys? Group 1. Lithium, sodium, potassium, rubidium, cesium, and francium. It has one of those. Or CBS. CBS is calcium, barium, strontium. I will always refer to them as CBS. See the CBS? And they're part of group 2. Check this out. Calcium, barium, strontium. Okay, now, if you remember anything about Chem 1, you remember that as you go down, what happens to the radius of the atom? It gets bigger. As it gets bigger, they don't care if they get their electron back or if they give it away. So that's why they easily dissociate. They'll give it up easily. Okay, so group 1 has, if it's a group 1 or if it's CBS with hydroxide. If it's with hydroxide. Any of those with hydroxide. So some examples, the famous that we use all the time, sodium hydroxide, group 1 element, hydroxide. Give me another group 1 element. And ammonia. Last year I called this the Big Daddy rule, or 2 years ago. So we have this pimp here. You guys see my Big Daddy? Do you see his cane? If you were to look closely at his cane, group 1 elements are there. Lithium, sodium, potassium, rubidium, and cesium. They're all there. And then on his cup is nitrates, because all nitrates are always soluble. And he actually should have ammonium on there also, because ammonium's always soluble. So I'll say Big Daddy rule. That means you know, okay, it has group 1. It's going to completely dissociate. So Big Daddy rule means it has those elements in it. Okay, so anytime group 1 is present, or ammonium or nitrate, it's automatically dissolving completely in water. It will 100% dissociate. It has to have hydroxide. Or it can have ammonium. It can have any of group 1, any ammonium, calcium hydroxide, barium hydroxide, strontium hydroxide. So you can have calcium hydroxide. You can have ammonium hydroxide. You guys get the gist? So the question is, what's weak? Well, everything else that's not on your list. Okay, we don't have time for you guys to memorize everything. So if you can just memorize what is strong or what makes something strong acid or base, then everything else is weak. That's what I'm saying. I don't want to tell you. I can tell you what's weak. Like
Are we still talking about like strong electrolytes?
Yeah, like, yes, we're still talking, because, so, the question is, are we still talking about strong electrolytes? Yes. Because if you know it's a strong acid or base, you know it's a strong electrolyte, it'll completely dissociate. If it's weak, it's a non-electrolyte, or it may not even conduct electricity. So let's go over it. Now that you have those rules, which I'm probably going to go over on Monday too, let's go over it. Okay, list whether each of the following is a strong, weak, or non-electrolyte. If it is strong, write the equations. So letter A, is that strong, weak, or none?
Strong.
Why?
It does H much better.
And there's two, very good, there's two or more oxygens and hydrogen. So you're going to write strong electrolyte, or you can write SE if you even know what that is. Electrolyte. Or you just write strong. Now, so you pour this acid in water, you're telling me it's going to dissociate. So when it dissociates, this is how it's going to look. This is how it looked to begin with. Then you pour it in water, and this is just like water on here. Pour it in water, and it dissociates to a hydrogen ion and a perchlorate ion. We have like a no, I didn't. We have a love-hate relationship. I dropped it one time, never forgiven me. It fell. So there's a dent here, so if you see it kind of get weird there, it's a dent. This is mine anyway. All right, next one. What do you think, guys? Strong, weak, or none?
Weak. Or non, because that's a carbon.
It has a carbon. It's a carbon-containing compound. Not to mention, it's two nonmetals put together. So it's a non-electrolyte. It's non-electrolyte. So we don't have to write a dissociation because nothing's gonna happen. How about C? Strong, weak, or none? Weak. Weak? Strong? Why? Big Daddy rule, guys. Group 1. Group 1 element makes it strong. Strong electrolyte, and it will, lithium hydroxide. This is my lazy hair day. It's like more complicated to do it. So it'll completely dissociate. Understand, all we're doing is dissolving in water. That's why water's not a part of our equation. I put it up here just so you know. It's just for to dissolve. Okay, letter D. It's two nonmetals. And I have to say, and I didn't go over this, ammonia is a weak base. Okay, so if you want to write down here, weak base. It's not in the strong category. And right away you probably would have said non-electrolyte, but it is a base. And it's a very, very weak base. We call these nitrogenous bases. Anytime you have a nitrogen with hydrogens, it's a nitrogenous base. So it's a weak electrolyte. I'll just put weak. You get it, right? So it's a weak electrolyte, yes sir? Now, let me show you something. Weak, and we will get into equilibrium. Anytime you mix it with water, and this one I am including it because this is an equilibrium problem. Plus water. What happens is you have a dissociation, but slightly. It like moves back and forth. So sometimes you'll have ions and then it'll go back. And then you have ions and then it'll go back. It literally does that until it reaches an equilibrium. This sign is a forward arrow and then a back arrow. And this is the stuff that we will get into towards the end of the year. February. beginning of our year. This is equilibrium, so it's weak. Next one we have group 1 element, sodium chloride. It is salt. Big Daddy rule, it is strong. Strong. Go ahead and write on your papers how you think it will dissociate. How do you think it'll dissociate? As a matter of fact, I'm going to go ahead and pause it there. Okay, so here are the results for letter E. The way since it's strong, it'll completely dissociate, meaning one arrow going towards the right, and you should have sodium positive plus chlorine minus. F, it's weak because it's a weak acid, and if you take a look, there are 2 oxygens to 1 hydrogen. Guys, this is a polyatomic ion. So when you're doing that comparison, you're only comparing what's in the polyatomic ion, the oxygen, to the hydrogen outside the polyatomic. Okay, because I bet you some of you added them together. Yes. This is actually a carbonated acid, and they're always weak. So if you have an acid that contains carbon, because even carbonic acid, like if I had carbonate, carbonic acid, look at it's weak. Carbon, what do you mean? Like carbonate, but we can just have carbon. No. I mean, you could, but even if you throw some carbon in water, it's not going to dissolve. So it'll be a non-electrolyte. So if you have any carbon-containing acid, it's going to be weak. Now, you could have drawn it this way, or you could have drawn it with water, and then it producing that. Either way is acceptable. Okay. And then the last one, ammonium chloride, it is strong because you have ammonium yielding ammonium ion and chloride ion. Okay. Any questions? Yes, sir. Well, you need to be careful because most carbon-containing compounds, and I'm talking about it just having carbon. See how that hydrogen comes after carbon? Or you can have C2H6. Those are just carbon-containing compounds. Yes, non-electrolyte. But if you have an acid that has carbon, like sulfuric carbonic acid or like acetic acid, these are weak because acids are weak. Weak acids are weak. Yeah, like glucose or sucrose, those are going to be non. You have to be careful. If the hydrogen comes in front of the carbon, then you know that's an acid. Any questions?